Alright, so today we're going to be doing 4.9, which is going to be notes on completing the square. So completing the square is a process that we use in algebra, which allows us to obtain a perfect square trinomial when we do not have a perfect square trinomial. So it can take a quadratic in standard form and convert it to vertex form. So sometimes quadratics are already in perfect square trinomials. So with those type of quadratics, we can actually just factor them and use this process, okay? So noticing the left side here, I want to look for factors of 4 that add up to 4. Any ideas?
2 and 2.
Good, 2 and 2. So I just factored that into 2 binomials. So those are equivalent expressions on the left, making those equivalent equations. And then how can I rewrite an identical binomial?
X squared.
Good, x plus 2 squared. So now from here, if our goal is to actually solve this, we want to get x by itself. And what mathematical operation can we do to get rid of a second power?
Square root.
Square root. So I can take the square root of both sides. And I'm going to do that up here because I don't have any room. That's x plus 2 is equal to plus or minus 5. So the square gets rid of the square root gets rid of the square, and then it always becomes plus or minus when you take the square root of a number.
Why is it always?
So we've kind of been talking about this like a bunch of times over the last few days, but the reasoning is if you have a value of x squared equals 25, that x can be a negative or a positive 5 to get 25, right? So that's the reasoning behind it. So from here, we then want to solve for x. So we are going to subtract 2 on both sides. Can somebody get that? Thank you. So that gives me x equals negative 2 plus or minus 5. So, hi.
Find the possible rating.
Sure. Thank you. When you move the number over to the other side, you always put it in front of the plus or minus. So that means we have two solutions. We have x equals negative 2 minus 5, and x equals negative 2 plus 5. So what is negative 2 minus 5?
Negative 7.
Good. And then what is negative 2 plus 5?
3.
So you have two solutions. So you'll often see these written in these squiggly brackets, and they will say negative 7 and 3. So that's the final answer. So did you have a good understanding of that process we used there? Yes.
So does the subtractive one always come before like the addition equation?
Good question. Yeah, whenever you bring over, whatever you bring over, whether it be subtraction or addition, depending on the operation, you always are going to put it in front of this plus or minus sign.
Okay.
Okay?
Wait, so then how do you know how to write it? Like, because negative 2 minus 5 is negative 7.
So the plus or minus indicates we have a version of it that's a plus and a version of it that's a minus. So you always rewrite one as the plus and one as the minus. And that sign that changes is always in the middle. Yes?
I think she's asking, like, how do we know what order of it?
Yeah, like.
Oh, it doesn't matter.
Oh, okay. So I could do like 3 negative 7.
You can. You'll see I usually write it in chronological, like, or numerical order, like the lowest and then the highest.
Okay.
But no, you don't have to.
Okay, thank you.
You're welcome. Yeah, a set doesn't matter the order. Okay, so this question here, we're looking to see what we can do to factor this. So what are factors of 36 that add up to negative 12?
Negative 6.
Good, negative 6 and
Negative 6.
negative 6. So the whole idea of a perfect square trinomial is it's always going to factor into 2 identical binomials, okay? And how can I write x minus 6 to the second power? Well, I just kind of told you the answer. Square it. And then what can I do to both sides?
Square root.
Square root, square root. That gives me x minus 6 is equal to plus or minus 3. So x is equal to 6 plus or minus 3. So I have two answers, right? I have x equals 3, and I have x equals 9. Does everyone see where I got those from? X plus 3 and then x minus 3. Or 6 minus 3 and 6 plus 3. So this concept is just to get you warmed up for completing the square. Okay? We're going to be using that concept in completing the square. So that's not like the end all be all or anything. It's just to get you thinking about how you can factor these and then what you can do to solve them. So the whole idea of this lesson is not every trinomial will be a perfect square trinomial. So we actually have a way in math to force it to become one. So we use this little formula right here. It's going to be b divided by 2 squared. Okay? And that allows us to actually factor these into perfect square trinomials. So sometimes there's going to be a c value there, and sometimes there will not be one. So when there isn't one, what you do is you use that formula. This right here is your b value, okay? You take half of that number. What's half of negative 10?
Negative 5.
Good. What's negative 5 squared?
25.
That's what goes here. Now, if you go to factor it, you're going to notice it factors into 2 identical binomials. Factors of positive 25 that add up to negative 10?
Negative 5. Right.
Negative 5 and
Negative 5.
negative 5. You'll also notice that it always factors into whatever half of that term is. See how it factors into whatever half of that term is? Always. Okay, just to save you the time. So, what is half of 6?
3.
What is 3 squared?
9.
See how you now came up with a perfect square trinomial? Factors of 9 that add up to 6?
3.
3 and 3. And that's also half of the original number, right? You see how it works? Okay. So you're basically coming up with a number that will make it factor the way you want it to. So as we go into Algebra 2 from Algebra 1, Algebra 1 is a lot of solving what's in front of you. Algebra 2, you're learning ways to manipulate numbers in ways that you want them to go. Okay? So this is kind of what we're doing with completing the square. So what is half of a half?
Quarter.
A quarter or a fourth. What is a fourth squared? 1/4 squared. What's 1 squared?
1.
What's 4 squared? 1/16. Now, nobody's going to sit here and find factors of 1/16 that add up to 2. 1/2, I mean. So, remember that trick I told you earlier? The number will always be half of this number. What's half of half again? 1/4. And if you want to check your math here, you could FOIL this out. And when you FOIL it, you will get this. These are equivalent expressions. Okay? So that's a way to check your work. So is everybody kind of understanding that concept of taking half, squaring it, and that concept? Okay. So now we're going to go into actually completing the square on a math problem. So we're going to use those concepts we just talked about in the problem. So the way this is set up is good, but there are a few things I'm going to change about it. So divide all terms on the left, not on the right, just on the left by A. And the reason for that is I do it that way so that you can avoid fractions. So I find that in my years of teaching, this is just a personal preference, when I start putting excessive fractions, you lose whatever it starts making it hard for you to understand what's going on. So when possible, I try to avoid it in more complex problems because I feel like I lose my students when I'm trying to sit there and be like, let's find an equivalent fraction, and then you're forgetting what other stuff we were doing. So I'm going to avoid fractions as much as possible, okay? And another thing is, we're not even going to write it here. We're not going to use initial vertex form. We're just going to write it as its final form. So I kind of simplify the process a little bit. Everybody teaches it a little bit differently. So here, let's go ahead and get started. So the first thing you need to do when you're completing the square is if you have a c term, everybody know what a c term is. It's the term without an x. You need to get it to the other side of the equation. So if I do that, I'm going to end up with 4x squared minus 8x is equal to negative 3. So you see how I moved it over. Now when you move it over, you basically leave a space and you have to fill that void with something else, kind of like we did on the last few problems on the last page. Before we fill that void, we need to then make sure our a value is 1. Is this number 1 or is there no coefficient? No. So what we have to do here is we have to factor out that 4 on this side. So is everyone with me on what we did so far? We moved the c over and then we factor out the a term. Alright, so now within these parentheses right here, I am now going to do that process we were doing on the last page, filling in this blank, right? So what is half of negative 2?
Negative 1.
What is negative 1 squared?
1.
So I have to add a 1 here. Now, all of the rules of math still apply through all these new processes we learned. Can you just go about adding a 1 to one side of an equation? No, because it imbalances the equation. It's like a scale. You have to keep it balanced. Now here's where it's tricky. Think about it logically. If I were to try to simplify this out, what would you do with this 4? You would distribute it, right? Which would mean this 1 is actually not a 1. It's actually a 4. So did we actually add a 1 to this side? No, we actually added a 4. So you have to add a 4 over here. So the rule is if you have a term on the outside, when you go to find the term that gets added over, you need to multiply this term by this term to get what we actually added to the other side. Does that make sense? So we didn't actually add a 1, we really added a 4. Yes, exactly. So now over here I can factor what's in the parentheses into two binomials. And over here I can just simplify this to 1. So I just added those two numbers together over there. Now, what are factors of 1 that add up to negative 2?
Negative 1.
And?
Negative 1.
Negative 1 and negative 1. Just like earlier, it's going to be half of that term right here, the b term. And then how can I rewrite x minus 1 times x minus 1?
X minus 1 squared.
Squared, very good. So this is kind of the stage of limbo here you get to. You get to this point where you have something is equal to a number. You have something squared, sometimes you have a number on the outside. So this is the stage where things can go one of two ways, and we're going to go both ways. You can find vertex form, or you can find values of x. So I'm going to find the values of x over here, and over here we're going to proceed with vertex form. So vertex form, do you remember it's y equals ax minus h squared plus k. Do you remember learning about this in my class?
Yeah, I don't remember the formula though.
Well, yeah. That's why I wrote it, because I figured you wouldn't remember it, but you recognize it, right?
Yeah.
So from here, are we close to this form?
Yeah.
Yeah, what's the one thing off from ours?
It's supposed to be plus k not equals k.
Yeah. So what can we do to get this 1 back to this side?
Subtract it.
Good. So our vertex form is actually y equals 4x minus 1 squared minus 1. You got to bring that 1 over. So now do you see how we have full vertex form here? So this equation and this equation are equivalent. If you were to graph these on Desmos, they would graph identically. One's in vertex form, one's in standard form. Alright? So, now we can also use this form to obtain values of x. So I'm going to write it down over here. Now your goal is to get the parentheses by itself. So what can I do to get rid of that 4? Good. That gives me x minus 1 squared is equal to 1/4. What can I do to both sides to get rid of a second power?
Square root.
Square root. That gives me x minus 1 is equal to, plus or minus, whenever you take a square root, 1 over 2. I just took the square root of the top and the square root of the bottom. You with me? Alright. Now what can we do with that 1 on this side here? Add it over. That gives me x equals 1 plus or minus 1/2. Our final vertex form, you can write it over here. It's just 4 x minus 1 squared minus 1. Now, looking at this right here, this means our x has two solutions. X equals 1 minus 1/2. What's 1 minus 1/2?
-1.
Just 1/2,
Oh.
right? 0.5. And then what's 1 plus 1/2? 1 and 1/2 or 1.5. So those are our two solutions. You can write them as fractions or decimals, I don't care. Please write them as fractions or radicals if they are not terminating decimals. Does everyone understand what I mean by that?
Like 0.25 or 0.5 or something like that.
Those are terminating. If it's like in the calculator, like 0.333 repeating, leave it as a fraction. Okay? Sure. So, does everyone understand that process? I know it's a lot, but did you understand each step? Even if you didn't memorize each step. Alright. You have a question?
Oh wait, what do you write on that bottom line?
I zoomed it out if you want to see. So, just to give you some solace, this is one of the harder types of completing the square problems. There's easier ones out there. Alright, you ready to move on? So, we are going to go ahead and do number 7. We're not going to be doing number 8 today. It is a fractional mess. But we can, if you want to try it, you can. But alright, number 7. So, the first thing you want to do when you're going to be completing the square is if you have a C term, you need to get it to the other side if it's not already over there. Okay? Because the whole goal of completing the square is you're trying to create your own C term that's going to do what you want. And it's not going to do what I want if I have that existing C term there. So that's all I've done so far is I brought the C term to the other side because I'm trying to create a new one. The next step is if you have a number in front of the x squared to factor it out. Do we have anything to worry about right now? No. So we're going to skip that whole step because we don't have anything to factor out. So is everybody understanding why we're skipping that step? Okay. So now we can just move into the next step, which is half of this number squared. What's half of 4?
2.
2 squared? 4. If I add 4 to one side, I have to add 4 to the? Good. So see how in the last problem we had to multiply this number by what's on the outside? Why didn't I have to do that this time? Yeah, there's nothing there. So if there is, you do it. If there's not, don't worry about it. Now you can just simplify on the right. That's -7, right? And over here, this just factors into 2 binomials. What are factors of 4 that add up to 4?
2.
Good. So how can we rewrite x plus 2 times x plus 2?
X plus 2.
Good. Okay, so here we're in the state where we can either go for vertex form or solutions, but as you can see, we want both. So at this point, we'll do one side for vertex, one side for solutions. So vertex form is a lot easier. All you have to do is y equals, oh, I'm cut off on that side a little bit, there you go. Y equals whatever's on the right, and then bring over what's ever on the left. So if it's subtraction, it's going to become addition. That's your vertex form. Now, you can't just find vertex form using anything else, but if you have a quiz, you could check your work on Delta Math or not Delta Math, Desmos, by graphing both and making sure they are on the same graph. Okay. Now to find the solution, I'm going to just rewrite what we have. And then what would I do to both sides at this point?
Square root number.
Square root. This becomes plus or minus I radical 7. Why did I put the I there?
Because it's the square root of a negative number.
Good, it's the square root of a negative. And is there anything I can do to reduce or simplify radical 7? No. So I just have to leave it as is. So I can take over the 2. And that's my final answer. Now you could write it out as 2 separate values, but why can't I go any further with this? It's imaginary, yeah. I can't combine a real number and an imaginary number. So what that means is when your result is an imaginary numbers always come in pairs, one negative, one positive, as you can see, the plus or minus. And that means that your vertex doesn't cross, or your equation doesn't cross the x-axis at all. And that makes sense, because from vertex form, do you remember how I taught you how to identify the vertex by looking at it? What is the vertex of this? Negative 2, 7. So at negative 2, 7, it sits at negative 2, 7, and then it goes up from there. Wouldn't it never cross the x-axis if it starts above and then goes up? So that's why. It's imaginary. Alright, is everybody good with skipping the fraction problem?
Yeah, can you go back to that real quick?
Right there? Alright, so we will skip the fraction problem, and I'm not going to give you any fraction problems on your homework either. Now, as for Delta Math is a system that it comes up with problems. I don't individually select them. So I can't say for sure that none of them will come up, but I doubt there's going to be a really hard one. If so, just you can ask me for help. But I tried to make it so they don't come up. We'll see if it works.
So all the graphing Delta Math problems, it's scaling the graph and stuff, and it was really tough for me to figure out how big it was and stuff. And I think I skipped some of the problems.
Which ones?
For graphing functions and stuff. There's a lot of it was really tough for me to get down. So I thought.
Oh, okay. We'll talk about it later, though. Okay. So is everyone good with that question? Okay. So let's try number 9. So what do you notice about the C term in number 9? Yeah, it's already over for you, so you don't have to move it over. So I don't have to move it over, so I'm just going to factor out that A term. So is everyone good with how I got to that step right there? Take out the 3, leave room for the new C. Take out 3, leave room for the new C. Now, how do I find my new C again?
B over 2 squared.
Which is? Anyone know? Negative 5 squared, which is what?
25.
Good. 25. Negative 5 squared, 25. Did we actually add a 25 here? What did we really add here? 75. We factor this into 2 identical binomials. Factors of 25 that add up to negative 10. And negative 5. How can I rewrite that?
X minus y squared.
Good. So from here, vertex form is just this. Does everyone see how I got that? Subtract over the 144. Alright, so now we want to get solutions for x, so how would we do that here? Divide by?
3.
Mm-hmm. Then what?
Square root.
This breaks up into square root of 16 times the square root of 3. Which one of those can I simplify?
16.
Good. My last step. Add the 5, right? That's my answer. Alright, so let's talk about it for a second. Does this graph cross the x-axis?
Yes.
Yes. These solutions are real, they're just irrational. So what that means is, I technically have two solutions here. 5 minus 4 radical 3 and 5 plus 4 radical 3. That's what that represents, two different solutions. Those have decimal approximations if you put them in a calculator. That means that our graph does cross the x-axis, it just does so at an irrational number, like 1.6735 or something like that. So real, imaginary is not real, and those don't cross it. But irrational numbers are still real numbers. Just like irrational people are still real people, right?
What?
Way to remember it.
Is that even?
Well, they are, but some rational people are not.
But imaginary people are definitely not real. So that's the difference.
They're real to me.
Yeah. Well, they're still, they have a significance. They're just not. All right. Let's try the last problem of the day. So I need to get rid of this c term, so what can I do to it?
Add it.
Do I have anything to factor out here? So I can start by taking half of this and squaring it, which is? Good, 64. If I add it to one side, I have to add it to the?
Other side.
Good. Factors of 64 that add up to 16?
8 and 8.
Good, 8 and 8. I can rewrite this. So the ones without the factoring are pretty easy, right? Much easier. Without the factoring out of a term. Vertex form of those, everybody should be able to do. Those are pretty easy, I think. Now, solutions can be a little bit more tricky. Square root, square root. This breaks up into the square root of 16 and the square root of 5. Which one can I simplify?
16.
Good. Last step.
Subtract the 8.
Good. That's my answer. Does it cross the x-axis? Yeah, crosses it twice, doesn't it?
Yeah.
At two very random spots. So, let me stop this thing.